You're watching the Air and Space Channel.
When Germany first went to war with its attack on Poland, she had relatively conventional aircraft. Her fighters, bombers, and transports all had counterparts in other air forces, although the Luftwaffe generally was numerically superior. Whilst most nations were trying to avoid conflict, Germany was consumed by a burning need to embrace war as a matter of honor. On the other hand, at secret test centers deep inside the fatherland, the Reich's best scientists and engineers were thinking about concepts quantum leaps ahead of all those in other nations, testing every type of innovation far beyond the pale of normal expectations. This produced a mixture of outright failure and unprecedented success. Often surrounded in half-truths, the results became an amazing broth of myth and reality. Germany's incredible miniature fighter competition, however, was no myth. It was a reality that did take place, and the results were marveled at long after the Second World War was over. During the final stages of World War II, Germany, in desperation, rushed to exploit its staggering developments in jet engines, rocket motors, and aerodynamics to maximum advantage. At first, they attempted to create advanced war-winning aircraft, but as time grew more desperate, they hoped to manufacture cheaper aircraft in massive enough numbers to push back the Allies. It was when Germany was on her knees that the miniature fighter competition was born. Germany had been able to produce fighters and bombers powered by jets and rockets. Both types proved their worth with unqualified success whenever they went into frontline service. Unfortunately for the Luftwaffe, they were too few and arrived much too late. The Messerschmitt 262 was without a doubt the best fighter aircraft of the entire Second World War, and beyond. Such was Germany's technological advantage.
The ME-262 was the most formidable aircraft of World War II. When we tested the Messerschmitt 262, it had a top speed of 568 miles an hour. This was a quantum jump in performance.
By way of further innovation, the Walther liquid-fueled rocket motor was able to propel the Messerschmitt 163 Comet point defense interceptor to higher speeds than any other aircraft of the war, including all the jets.
The Comet was definitely the most spectacular aircraft of the Second World War. It was extremely fast, extremely remarkable as far as the technology behind it.
These by no means were Germany's only innovations. There was also the least sophisticated of Germany's new power plants, the Argus pulse jet. A rudimentary but effective and economical device which powered the infamous V-1 flying bomb. Perhaps it could have tipped the war in the Nazis' favor had it been employed sooner. As the war ground onto its final stage, 3 radical German fighter projects were rushed into development, and some even onto production. They were the emergency fighter, the people's fighter, and finally, the miniature fighter. Incredibly, despite all the shortages that arise when losing a war, each of the successful aircraft were a product of vigorous competitions between competing designers. Or at least, that's how it was supposed to work. Contracts for aircraft development were issued and managed by the German Air Ministry, known as RLM. In mid-1944, the RLM's priorities were to make the most of the nation's crippled aviation industry, and to defend the fatherland from almost certain annihilation. Having no other choice, they were obliged to rely upon the mere remnants of a once great production machine, hoping to produce results that just might save their nation. Many new designs were based around the Heinkel HES 011, Germany's most ambitious jet engine. One that was never ready, even by war's end, although a prototype had been assembled. It was hoped that the awesome power of Heinkel's engine would help propel the winner of the emergency fighter competition to victory.
The emergency fighter program. Basically, this called for an airplane to be built within a certain set of parameters. Number one, it had to be jet powered. Number two, it had to be extremely high performance for its day, and that was with a max speed of over 600 miles per hour. And number three, it had to have a minimum range of about 800 to 1,000 miles.
The RLM was looking to develop an extremely advanced interceptor, one capable of downing the expected American B-29 Superfortress, the most advanced bomber of its time, and one capable of reaching heights never previously even contemplated. The Focke-Wulf TA-183, sometimes called the Hookabine, would have been the ultimate jet interceptor, perhaps even for some years to come. The design, together with its equally advanced weaponry and Heinkel's engine, employed every scrap of new technology available, all of which were exclusive to the Third Reich. The company bested a competitive design in the Junkers EF-128, although by a narrow margin. Either of these outstanding concepts would have simply staggered any Allied designer on first sight. The level of advanced aerodynamics employed in both instances would have been quite mind-boggling. Had they been on hand just a few months earlier, they would have been a difference maker. Unlike the Messerschmitt 262, the emergency fighter was to have a single jet engine only, and was based around the yet-to-be-delivered HES-011 jet engine. An earlier Jumo 004 type filled in as a substitute. Although either combination would likely have had a significant impact against the expected fleets of American B-29s had they had actually been employed against the Reich. However, the TA-183 was never completely finished, falling into British Army hands just before Germany's surrender. As a consequence, Focke-Wulf's ingenious interceptor never rose into the air. Although it's more than possible, it may not have been needed anyway. Poetically, the much-feared American Superfortress was never actually intended for European use, and the one time an example did fly into Britain, it was merely a ploy to divert Germany's efforts into projects such as the Hookabine. It was a ruse that clearly worked. A further reflection of the fast deteriorating state of Germany's war fortunes was the People's Fighter. The Reich was showing clear signs of a diminishing supply of both traditional materials and pilots. With dwindling numbers of airmen, could the Nazis rely on German boys to man their cockpits? Some in the party were seriously considering this idea.
They were planning to use teenagers out of Hitler Youth or out of a National Socialist Flying Corps, which at least had some basic training on gliders, put them on single-seat jet fighters and hope for the best.
Even if the Germans had succeeded in building a schoolboy air force, there was still the question of building new aircraft with what few factories and materials were left. To keep airplanes rolling off the assembly line, another source of human energy would definitely be pressed into service. And by no means for the first time.
By the end of the war in Germany, a lot of the workers in the armament industry were not there voluntarily. They were forced laborers, slave laborers. You're looking at the V2 rocket, you're looking at the Messerschmitt 262, you're looking at the Comet, you're looking at the 162 as well. There was a lot of people with little enthusiasm, which raised the risk of sabotage.
Dr. Richard Vogt of the Blohm & Voss Company had long been aware of the shortages of imported metals such as aluminum. He had often experimented with tubes made of steel, as iron was still in abundance. Vogt's entry into the People's Fighter competition, the BV-211, consisted primarily of two steel tubes welded together in an overlapping position. All the other components were simply bolted to this strong and effective frame.
Vogt, with his brilliant engineering ideas, he could see that the aeroplane needed to be mass-produced, and he designed it in such a way that it could be mass-produced, almost like a model aeroplane kit. Various parts could be farmed out to unskilled people and all brought together and bolted together, the fuselage being a tubular affair, with the aeroplane just simply built around it.
Ernst Heinkel wasn't running his company at the time of the competition. In fact, it had more or less become the personal property of Hermann Göring. Still, a highly advanced lightweight aircraft did emerge from his factory in the form of the HE-162. Built largely out of wood with a jet engine mounted aloft, it was a clever concept, and when it won the RLM competition, it proved effective. However, it is likely that the alternative Blom and Voss design would have been the better aircraft, and that the contract may have gone to the Heinkel Company as a favor to the Vice Fuhrer. Built largely with slave labor, the Sparrow, as it was named, was a sophisticated aircraft, probably too much so to be placed in the hands of less than enthusiastic slave laborers. Detailed work with the world's most advanced technology was not best achieved under the lash. Less than 50 HE-162 Sparrows ever took to the air, although almost 300 were in production as the war came to an end.
The Heinkel 162, it was a nice idea, but whether or not they would have been able to put them in service in 1945, you need the pilots, you need the fuel, you need the time to actually train everyone, the ground crews, etc. They were running out of time.
The final fighter program was by far the most desperate and bizarre of all. It was the miniature fighter competition. Almost as the war was coming to an end, the German Air Ministry identified a requirement for the cheapest fighter possible. These aircraft would have to be diminutive to the extreme, a pygmy amongst other types. And the concept actually had some precedence. By the time of the competition, Germany had already created a substantial list of tiny aircraft for highly specialized missions. Long before the RLM search for a miniature fighter, there had been numerous attempts to use solid fuel rockets to propel very light aircraft. The Opel RAK-3 rocket-powered glider is perhaps most well known. Its fuel was just black powder packed tightly in a number of canisters and ignited all at one time. As comic as these attempts might seem, they led the way to more ambitious exploits. Other types of rocket-powered aircraft started to appear, mostly in the hands of hobbyists, sometimes with wealthy sponsors. However, this interesting pastime started to get somewhat out of hand, and the Nazi Party stepped in to get things under control.
At that time, Germany decided rocketry would now become a state secret. All amateur rocket experimentation would be now outlawed. It would be against the law to shoot off a rocket just for pleasure or for experimentation.
Of course, the Nazis themselves never lost interest at all. Rather, they saw great potential in what was fast becoming a science, especially as more advanced chemical fuels were being developed. Within a few years, there were two types of liquid-fueled rocket motors available. Firstly, there were the A1s and 2s, developed by von Braun, stepping stones to his infamous A4 ballistic missile. It was fueled with a mixture of alcohol and liquid oxygen. The other was the Walther, chemically fueled rocket. This used hydrogen peroxide, pumped under pressure to mix with a reactant, which produced a tremendous, not to mention highly dangerous, thrust. In 1939, Professor Heinkel designed the HE-176. a small aircraft that was really little more than a glider powered by a small von Braun motor. However, it was this prototype that actually made the first liquid-powered rocket flight. It has to be said that von Braun himself had previously put forward a similar type, which was to be fired vertically from a ground installation, like a missile. The project was never completed, as at the time, the RLM considered both offerings too advanced to be of any great use to the war effort, although they were not entirely forgotten. The other type of cheap, yet rather clever aircraft power came in the form of the Argus pulse jet. A primitive device, to be sure, although one that seemingly came out of nowhere when it put dread in the hearts of people throughout southern England. It had enough power to propel a small yet deadly projectile, the V-1 flying bomb. Looking like little more than a large stovepipe, the pulse jet emitted a hated low-pitched rumble which preceded a terrible explosion, from which there appeared to be no escape.
The V-1 had about a 1-ton high-explosive warhead, and when it hit the ground, it would explode with tremendous force. Sometimes the V-1 would create a crater 1,000 feet wide, sometimes 2,000 feet wide.
The secret
to the Argus pulse jet was simple enough. It was a valve much like a Venetian blind.
A pulse jet engine is a stovepipe. Air comes in, there's a small grid where it's compressed, and fuel then is pushed into this grid via air bottles. And then there's an ignition. It stops for a nanosecond or two, and then air comes in, compressing again, and it explodes and provides thrust. And so that's why the pulse jet engine was called a doodlebug, a buzz bomb, and when it flew, it went pop, 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 pop.
The device had just one Achilles heel. The problem with the Nazi flying bomb was it needed to be launched at speed, either from a powered ramp or an aircraft in flight. Given that the V-1 resembled a cruciform aircraft in every way, it's of little surprise that a piloted version should at least be tested, and so several of the type were modified into piloted aircraft. Courtesy of famed German aviatrix Hannah Reich, the main aerodynamic failings of the FS-103, as it was properly named, were at least improved upon.
The V-1, as they fired it off the catapult ramp, it was rolling over onto its back, and Hannah said that if they put controls in, she would fly it. She was the only person that could. She was tiny, 5 feet 2, and could get into this cockpit. She flew it, obviously a very high-risk affair, discovered the problem, and of course they were satisfied with that, but Hannah wasn't. She said, no, I want you to modify it, and then I'll fly it again and see that it really is the answer, which she did. Now, the second time round, they made a slight error. They didn't leave enough fuel, and she ran out of fuel and landed on the dunes on the Dutch coast and was quite badly injured. But she had made her name.
Even with her input, the main problem arising from the constant vibration of the pulse jet, which was so close to the pilot's cockpit, was never solved. And so Germany's buzz bomb miniature fighter, the Fiesler 103, was abandoned. Still, the sheer economics of making the Argus pulse jet insisted that it be considered for other uses, and so it was. The pulse jet motor was tested with aircraft as diverse as unpowered troop-carrying gliders to advanced trainers and high-powered night fighters. So much was learned, although where that knowledge would be ultimately applied was unclear. Curiously, there was one inexpensive pint-sized Homeland Defender that may have proved even more economical. This one didn't have an engine of any kind. It was simply a glider. but a glider with a unique job. Again, designed by Richard Vogt, this glider was especially designed to ram incoming enemy aircraft, in particular U.S. daytime bombers, and to hack off their tail sections. To protect the German pilots from the force of the collision, they were enclosed and protected in a hardened-prone cockpit. After having first been towed by fighters to a position above the enemy bombers, the BV-70 swooped down on their prey. Their diminutive size gave them an edge, as they were a tiny target for U.S. gunners to lock on. The same fighters would attempt to stay on as glider escorts, at least until Mustangs arrived. The concept may have seemed bizarre, although about the same time, Northrop and America were testing aircraft for exactly the same purpose. Another genuine miniature fighter which predated the official RLM competition was the Messerschmitt Me-328. The type's original role was that of a parasite plane, to be carried by the America bombers on long-range missions to attack the U.S. There were two versions of the Me-328, one being a fighter and the other a very small bomber, and there is some doubt whether, as an America bomber parasite, it would have served in one or both roles. In any event, this ambitious plan to attack the U.S. was abandoned by the middle of the war. Power plants for the 328 varied from two Argus pulse jets to a Walter rocket motor, to a Jumo 004 turbojet. It couldn't, however, have carried too heavy an engine, given its wooden construction. It is known that Hannah Reich flew the Me-328 when it was in a parasite configuration on top of a Dornier 217, although the exact purpose of this experiment has never been explained. A number of innovative miniature fighters were conceived to defend Germany's key industrial and military sites. By the middle of 1944, the Luftwaffe was looking for a purpose-designed target defense fighter. This need caused some to reflect on von Braun's point defense rocket fighter of 4 years earlier.
In 1939 and again in 1941, von Braun submitted a proposal for a vertical takeoff rocket plane. He argued that the most important thing for a fighter was to be able to reach altitude as quickly as possible and to engage the enemy immediately. Conventional aircraft required an airfield to take off and then had to search for the enemy. Von Braun's rocket-powered plane would take off vertically, possibly from a mobile launcher, and then follow a radio beam up to the vicinity of the target aircraft. It was only at the last stage, when the interceptor was about to engage the enemy, that the pilot took control.
It was only a concept, of course. However, von Braun's reputation had grown since then, and now a previously disinterested Luftwaffe was actually asking for a vertically fired rocket fighter. Heinkel was commissioned to produce a ramp-launched fighter, which was to be known as the Julia. It was mainly powered by the Walter rocket motor, and assisted in takeoff by 4 solid-fuel rockets. However, a few months into the project, Heinkel also chose to develop the basic design into something closer to the short takeoff Comet, a move that has never really been explained. Without a doubt, the most ambitious of all German miniature aircraft conceived during the war was the Bochem-Natter. This true vertical takeoff point defense fighter was one of the most complicated designs ever to fly, however briefly. The Natter was unique even amongst other unusual aircraft. Firstly, it was never actually commissioned by the RLM. It was an idea they had declined earlier. The project was adopted unilaterally by the infamous head of the SS, Heinrich Himmler.
It was clear that Himmler wanted to take the Natter under his control. At this stage, Himmler's power was in the ascendancy. He wanted the SS to take over armament development. Himmler offered to support Barkham, and Barkham accepted.
It was Himmler who authorized all the costs and even the building of the factory where the aircraft were to be assembled, as well as the actual construction of the individual aircraft, albeit under qualified supervision. The Natter would have been a true point defense fighter, much like another German rocket craft of the time, the Me-163 Comet. Its job was to defend specific targets critical to the war effort, although in many ways, the Natter could be seen as an answer to accuracy problems with earlier German missilery. With the Natter, a pilot could launch large numbers of missiles close to the enemy with great accuracy. Bachum's invention was perhaps more of a missile carrier. Though the Comet and Natter were both point defense fighters and used Walter rocket engine power plants, that's where the similarities ended. The Comet made a quick horizontal run before going almost vertical. The Natter, on the other hand, was simply fired on a ramp that was aimed in a totally vertical position. Due to the additional power needed to launch in a vertical position, similar to the Julia, 4 extra detachable solid-fueled rockets were added. Comets were particularly vulnerable to Allied fighters on takeoff, and even more so on landing. For this reason, the Bochum Natter's vertical takeoff ramp was designed such that it might be hidden in a wooded area, in the same way certain V-2 missiles were. Apart from its potential for clandestine takeoffs, a major reason for Himmler pursuing what was really a private venture was the Natter's weapons payload. The nose section was filled with the A6M folding fin air-to-air rockets, fired in a salvo. There was simply no possible antidote for these terrible, deadly weapons.
The R4M rocket missiles, when they struck a bomber, it wasn't a question of damaging it or downing it, it was a question of disintegrating the entire thing.
Allied concerns about the effectiveness of the A6M were such that advancing ground armies were under special orders to capture and destroy these weapons at all costs. Takeoff and attack were a precarious enough procedure for pilots, but descent was no easier.
The Natter for me is utterly fascinating. It was designed in such a way that it would actually come apart in flight after its engine had cut. At a certain height, the pilot was able to get out of the front part on his own and come down with a conventional parachute. The engines would come down by its own parachute. What that did was ensure that the whole thing could be reused, man and machine. And the interesting parallel that I draw is really it's the precursor of the space shuttle concept. You have a crew, you have an aircraft, it goes up, it does a job, but it comes back to Earth again and can be reused. And it's ahead of its time.
There were 36 Natters completed, although many were used as gliders to test the type's handling properties in the post-attack glide situation. There was only ever one attempt at a manned launch, and that resulted in the death of its young pilot. The designer, Erich Bochum, always claimed he never saw the Natter as a suicide mission. However, the risks of flying such a complicated machine were self-evident, and probably why the RLM declined and Himmler did not. Early in the war, de Havilland had developed its iconic Mosquito twin-engine fighter bomber. The type's performance was greatly respected by the Luftwaffe, especially as a night fighter. Knowing the Mosquito's secret was its strong wooden construction, the RLM sought to emulate the British success by using similar techniques in the construction of a miniature fighter. The secret involved pressing two types of wood laced with a patented adhesive in an autoclave. Wood was in abundance in Germany, and the German chemical company Goldsmith made a product called Tego film, which would be a good bonding agent. All went well, and Focke-Wulf produced its model TA-154, now named Mosquito, mimicking its RAF competitor's moniker. By now, the Luftwaffe had little choice but to rely increasingly on wood, so the Tego film process was used extensively. Then, one night in February 1943, RAF Bomber Command struck the town of Wuppertal and destroyed Goldsmith's only Tego film factory. In one of the war's examples of poetic justice, the bombing mission was guided to its target by a de Havilland Mosquito. However, by now, Germany's reliance on wood for aircraft construction was locked in, and therefore a substitute resin had to be found, and indeed it was. Not that far away in Leverkusen, the dynamite company produced a cold adhesive, which was known as an ersatz, or wartime substitute product, and it was available. Focke-Wulf continued production of their TA-154 using this new adhesive. Slowly, a few of the new German night fighters started to go into service. After a few months of flying, a wing broke off a later production model.
Tank actually took the action of grounding the 154s because the glue was coming unstuck. The stuff he had used earlier on was this very good adhesive, which was totally eradicated when the factory was bombed out of existence. And the new type of glue they had was not up to that grade and was actually coming unstuck, and they had a couple of crashes.
In November of 1944, the Luftwaffe High Command asked the RLM to issue a request for an extremely economical, very light fighter. Their specifications were dictated by two simple facts on hand. Firstly, jet engines were constructed of hard-to-come-by materials, and the Argus stovepipe was not. Secondly, an Argus pulse jet had powered the Me-328, which had flown quite successfully, and was likely the cheapest powered aircraft ever produced by the RLM. Following years of miniature fighter development, the actual miniature fighter program was a very short-lived event. The required specifications were so frugal that few manufacturers even bothered to respond. The power source was to be the Argus 014 pulse jet, and construction was to be mainly of wood. There was also to be an absolute minimal use of instrumentation. This bare-bones aircraft would be less sophisticated than many basic gliders. The initial speed necessary to fire the Argus engine could be achieved by catapult, solid-fueled rockets, or towing. Either way, it was expected that literally hundreds of the types selected could be produced and used to beat back attacking Allied bombers by sheer weight of numbers. Although a selection program was undertaken, it quickly boiled down to just three contenders: Heinkel, Blom-Voss, and Junkers. The Heinkel offering was the least difficult to achieve, although it probably didn't fulfill all of the criteria for a miniature fighter. It would require very little development. The company's designers merely had to take the existing 162 Salamanders, strip it of its BMW 003 turbojet, and replace the most valuable power plant with one or possibly two Argus pulse jets. Of course, there would have been a very considerable saving in cost and weight, but would the radically diminished end result have justified the effort? Possibly yes. As it was, there was no way that BMW could supply anything like the number of 003 jet engines needed, due to the raw materials being in such short supply. On the other hand, the airframe was a product of wood and slave labor, ingredients that Himmler's SS could always seem to find. However, the absence of the reliable Tego film bonding agent meant that the salamander was doomed to suffer the same fate as the German mosquito. Rather, like the fatherland, they were starting to fall apart. The second competitor in the miniature fighter competition, Blom & Voss, had built some of the world's largest flying boats, mammoth 6-engine aircraft, and now they were being asked to design a flea driven by a stovepipe. But loyalty prevailed and great minds took up the cause. Their design never left the drawing board, however. It still reflected the company's desire for uniqueness and the brilliant mind of Dr. Richard Vogt. The BVP-213 likely would have done everything asked of it, although Vogt had chosen to use more metal than requested. He always wanted his aircraft stronger. Had his People's Fighter with tubular steel design been chosen, then the Luftwaffe might not have been left with a fleet of disintegrating salamanders. The third competitor, the Junkers EF-126 Ellie, was probably more like what the RLM had expected. However, as the war had reached its final stage and the Reich was in its death throes, major services stopped and nothing was working anymore. As a result, all that Junkers had to show for their effort was a full-size wooden mock-up and the plans, together with some wind tunnel test results. And then, the RLM quickly canceled the whole program at the end of December 1944. Even so, it's known that some calculations were still taking place in late March of 1945, just before the Soviets arrived. The Allies were anxious to snap up any scientists and technology left behind by the Reich. The great strides they had made in aerodynamics and in engine technology were assimilated into aircraft of the Cold War. Similarly, small-scale designs as those of the miniature fighter competition were toyed with and tested. The Soviets hit the miniature fighter jackpot at the Junkers plant in Dessau. There, they found the wooden mock-up of the EF-126 and Junkers' best pilots and brightest designers and test pilots. They were even handed the manufacturing plans for the aircraft. The Soviets were particularly eager to develop jet aircraft of any type and quickly ordered prototypes constructed. Early glider tests were a deadly operation for even the best of Germany's test pilots. The Soviets had better luck rekindling old German technology when launching powered EF-126 from old German bombers. Though the tests were for the most part satisfactory, the pulse jet fighter idea didn't take off. The Soviets had the resources to build faster and more sophisticated jet fighters, which outmatched their tiny German copies in most every way, other than cost. In 1951, Britain launched their own miniature fighter, the Fairey FD-1. About 26 feet long with a wingspan of 19 feet, and with a fully loaded weight of 6,800 pounds, it certainly was as tiny as some of its German predecessors. The hopes of a nation did not rest on the Fairey Delta's shoulders, though. This was a research aircraft to see how Delta wings responded at transonic speeds. Taxi tests began in May of 1950, and on March 12, 1951, it was ready for its maiden flight, piloted by Group Captain Gordon Slade. Unfortunately, the aircraft had serious and dangerous stability problems, and the problems could not be resolved with additional modifications. Though 2 more airframes had been ordered, the program was ultimately canceled. The lone Fairey FD-1 continued to provide research data for future Delta Wing projects like the FD-2 and Concorde. The Americans first dabbled with miniature fighters during the war. In 1941, Bell Aircraft took up the U.S. Army Air Force's challenge of building a small, lightweight fighter using non-strategic materials. Like Germany's miniature fighters, the XP-77 was largely made of wood. It was a low-wing monoplane fighter, armed with a 20mm Hispano cannon fired through the prop hub, 2 half-inch Browning machine guns, and optionally, a bomb or depth charge. The project was plagued with problems from the get-go. Its 500 horsepower supercharged Ranger engine wasn't ready on time, and the aircraft was overweight. Underpowered and heavy, the XP-77 was difficult to fly. The Americans also had concerns about the glue used to bind the wooden aircraft, a problem the Germans experienced with their Mosquito and Salamander. The XP-77 project became less and less of a priority for Bell and the USAAF, and by 1944, it fizzled out completely. However, it wouldn't be long before McDonnell Douglas conjured up a new mini-fighter for the USAF, the Goblin. World War II ended with America becoming a nuclear power. It had successfully dropped atomic bombs on Japan from B-29 bombers. At the time, Japan had few interceptors capable of reaching the high-flying pressurized bombers. But with the dawn of the jet age and Cold War, all that would change. Jet-powered interceptors would be able to thwart an American nuclear assault against a Cold War target. The problem was no American escort fighters were available with the range and altitude to keep up with her bombers. But what if an aircraft could be made small enough to fit on board an American bomber? The McDonnell XF-85 Goblin was designed just for that purpose. At only 14 feet long with foldable wings, it was small enough to fit in the belly of a B-36 bomber. It was similar in concept to Germany's combination of an America bomber with an Me-328 Parasite plane. Testing began on a specially modified B-29 in 1948. The aircraft was launched from a hand-light crane in the belly of the aircraft. Once released, the pilot could take on any incoming interceptors. When the hostiles were cleared from the sky, it was time for the Goblin's toughest assignment, getting back into the bomber's belly. Turbulence made this a challenge, and during the first test, McDonnell test pilot Edwin Schoch crashed into the crane and plummeted back to the ground. He was, however, able to make an emergency belly landing and save the Goblin and his own life. Though the aircraft was repaired and refinements were made, the program was canceled. The Goblin would not be a match for the new Soviet interceptors it might tangle with on the way to target. As well, the development of air-to-air refueling meant that conventional jet fighters could serve as escorts. The miniature fighter competition was born from the desperation of a country on the brink of defeat with limited resources and an ample supply of imagination. Imagination that spawned a slew of other diminutive fighters throughout World War II designed for highly specialized missions. Some concepts were more successful than others, as Germany took a kind of shotgun approach in an attempt to create war-winning designs. In the end, as resourceful as the Germans were, they lacked the resources and manpower to reverse their fortunes.
As far as aviation in the Second World War, as far as aerodynamics, now the Germans were extremely advanced. There's no doubt about that. The swept wing, for example, was certainly the idea. Rocketry, certainly very advanced in that regard. But they didn't have the resources, they didn't have the time, they were not focused. A number of people tend to think of Nazi Germany as a monolith because you have a dictatorship, you have a clear line of command, you decide, you do it, if you don't do it, well, you pay for it. It was quite different. It was a polyarchy. It was complete chaos. It was a 15-ring circus. You had people doing all sorts of things, going in every direction. The Luftwaffe was like that. The army was like that. Weapons development was like that. It was complete mayhem.
A handful of miniature fighters were experimented with after the war, and although they did provide research data, they cannot outperform larger conventional aircraft of the day. In the end, the miniature fighters are an interesting footnote in aviation history. They had little impact on the outcome of the war, other than to drain some of Germany's resources.
You're watching the Air and Space Channel.